chemical equilibrium, we will be looking at equilibrium constants. Equilibrium constants. Now, on equilibrium constant, what is so specific concerning equilibrium constant, or the two important things you should take note on equilibrium constant are the phases. The phases and your reactions. The phases and your reactions. Now, when I talk about the phases, the two important phases you should take note while dealing with equilibrium constant is the aqueous phase and the gaseous phase. Those are your main concern. Then, when it talks about the reaction, is that you are taking note of the forward reaction, and you are taking note of the backward reaction. Are you getting it now? So equilibrium constant is denoted as K, and equilibrium is denoted with K, and equilibrium constant can be equilibrium constant. It can be for the concentration constant, or we can have the pressure constant. I get it now. So there is what we call a similarity. There is what we call a similarity between the two of them, or relationship, not similarity, relationship between the two of them. So this is the constant, and this is for concentration constant, and this is for pressure constant. I get it now. So, but before we get here, or before we get to this point, we need to understand how we can evaluate the constants for a particular equation, or for a particular chemical equilibrium. I get it now. Don't forget, equilibrium is talking about when chemical equilibrium is talking about when the compound in the product is also giving us, or is equal to the compound, the concentration. The concentration of the product is equals to the concentration of the reactants. I get it now. So at this state we have Kc. Then for pressure here, it is when the pressure of the product, or the partial pressure, let me put it that way, the partial pressure of the product is equal to the partial pressure of the reactants. And please take note, this partial pressure is relating to gas. Then for concentration of products, we are talking about the aqueous form and the aqueous form. Now, it means that there are times whereby they can ask you to find the concentration of the constants of your pressure. So we are going to get to that point, but first of all, let's deduce how we can write our concentration constant. Now, for example, you have a question like this. We have 2 SO2 in aqueous form plus O2 in gaseous form, the forward and the backward reaction. Then we have 2SO3 in gaseous form. Now, what you should understand that first of all, this is what we call, this type of reaction is heterogeneous. It is a heterogeneous chemical equilibrium. Why? Because we're having aqueous, we're having gas, and we're having gas. Do you get it now? Aqueous, gas. So it is heterogeneous. Now, another form again that you should take note of is that the theory of them, this is 2 molecules of the reactants here, 1 molecule of this reactant here, then it's giving us 2 molecules of the product. So this is the second form of heterogeneous chemical equilibrium. So you can understand this when you watch my previous episode. Watch the previous episode where I talked about homogeneous forms of homogeneous chemical equilibrium. So let's proceed now. Now what I'm trying to bring out that for us to write the equilibrium constant for this reaction, the equilibrium constant for this reaction in concentration constant is going to be Kc is equals to the concentration of our products over the concentration of our reactants. Then how do we get to write this, or how do we tend to represent this? Is that from here our product is just this, so we are going to be having SO3 brackets this our molecule, this molecule for this product is now going to be a power. It's going to be our power. Then we are going to have over, then our products, this is our product. We are done with our product. Then we are going to have our reactant. Our reactant here is SO2. Then the molecule become the power. Then 2, right, power. Then times, which is dots. You can use it as dots, which is times our O2, which is our second reactant. And take note, this our second reactant has its molecule as 1. So this 1 is raised to power 1. I get it now. So this is the representation for the concentration constants of this particular question. Now, in a case whereby you are now given some questions, you might be given the value of all these 3 things, these 3 compounds here. Then you evaluate. Now, when you evaluate and you have your Kc to be greater than 1, when your Kc is greater than 1, it simply means that the equilibrium will favor the product. And you should know that product is forward reaction. Your forward reaction is your product. But when the Kc that you get eventually as your answer, when the Kc you get is less than 1, when it is less than 1, when your Kc is less than 1, the equilibrium will favor your reactants, which is your backward reaction. Now, how do I explain this, or how do we explain this? I would use more examples in the next episode to explain this. But in this episode, what we need to get is that we need to understand how to write our equilibrium constant, how to write it, which is this that we just did. So let's take a look at 2 more examples here. 2 more examples where we have number 2, second example. Let's say we have N2O plus oxygen gas. This is also a gas. Then it's giving us the forward reaction and the backward reaction of 2NO gas. Now, what type of reaction is this first? This reaction is having a gaseous phase, and also having a gaseous phase. So this equilibrium is homogeneous. It is homogeneous chemical equilibrium. That is an example for another example for it. So for us to write our Kc, please take note, our Kc for this kind of equation or this kind of equilibrium chemical reaction is going to be What's our product? Our product is N. Don't forget the formula is products or over reactants. Concentration of product over concentration of reactant. So this is our product. Then the molecule, this molecule here 2 becomes our power. Then we go back to our reactants. This is products. Then let's talk about the reactants. Reactant is N2O. N2O. How many molecules of this N2O? It is just 1. Though it is not written, but it is 1. As long as it is not written, it is carrying 1. N3 raised to power 1 is that thing. Then let's take a look at the second one. Oxygen. O2. Oxygen. Then what is oxygen carrying? Oxygen is carrying half. Half is also 0.5. So you can just decide to use 0.5 since half is 0.5, or we use half is 0.5. Do you get it now? So you can decide to use 0.5 or use 1/2, whichever one. Anyone you want to use, either 0.5 or 1/2. So this is how to write the equilibrium constant for this particular reaction. Then when they now give you, when you are not solving questions on this particular thing, they can say NO is 2 mole per dm cube, N2O is 4 mole per dm cube, then oxygen is 2 mole per km. Then we cannot substitute all this into this place, substitute this into this place, then substitute this into this place, then we'll get our answer. But we are not going to be talking about that in this episode. That will be in the next episode. So let's take a look at another question. Okay, let's take a look at another question, which is the third one. This third question has to do with solid and 2NaHCO3 solid is giving us Na2CO3 solid plus CO2 gas plus H2O gas. Now H2O gas. Now take a look at this example 3 now. This is a form of heterogeneous. This is heterogeneous chemical equilibrium. Why? Because we're having solid here, we're having gas here, we're having gas here. I get in our products, our reactants. This is our reactants. We have just one reactant compound. Our reactant compound is solid. Are you getting it now? Our reactant compound is solid. Then our product is solid. Our product is also having gaseous phase and also having a gaseous phase. So they are in different phases. So to write this Kc here now, please take note. Don't forget. Now the Kc we are talking about here is that what you should not forget, that I explained earlier, that the equilibrium constant talks about the aqueous form and the gaseous form. Talks about these two forms, the two phases are the aqueous form and the gaseous form. The two important phases that you should take note of. Now in this particular equation here now, or this particular chemical equilibrium here, we don't have any business with the solid phase or the solid compound. Our equilibrium here is only going to be dealing with just the gaseous phase alone, just these two gaseous phase alone. So for us to write our equilibrium constant here now, we are going to just be having CO2. So our equilibrium constant here is just CO2. Then how many molecules of CO2 do we have? Don't forget, we don't have any business with this. So the only ones we have business with is this and this. because they are the gaseous phase and the gaseous phase, right? So our equilibrium constant is going to be written as CO2. How many molecules of CO2 do you have? 1. So raised to power 1. Then our H2O. Our H2O. Our H2O. How many molecules of H2O? Is also 1. So we have 1. So at this point here, we only have the concentration constant. The concentration constant for products only, because we don't have anything like gas or aqueous form in the reactant, so we are only dealing with just these two. So that is what it happens. Most times your equilibrium constant can only be your equilibrium constant can only be your reactant, as long as you are as long as the phase you are dealing with is just gas and gas, the gaseous phase and the gaseous phase. Are you getting it now? So that is what you have business with. You have business with your aqueous form, the aqueous phase, and the gaseous phase. So in the next episode, I'll be explaining properly. I'll be using questions and questions that involves calculation to explain and give more light on this equilibrium constant. So this is just how to write out your equilibrium constant. In the next episode, I'll also be talking about the relationship between the partial pressure constant, which is the pressure constant, and I'll also be talking about the calculation of the equilibrium constant. Because relationship between the pressure constant and the concentration constant. So don't forget to subscribe, like, and also share this video, and follow up for the next explanations on the other subtopics. Thank you.